Hi, and welcome to this lesson where we're going to look at how we find the area of different quadrilaterals. Okay, so we're going to start by finding the area of rhombuses. Now, to find the area or the formula for an area of a rhombus, we can turn it into a compound area activity. We start by drawing the diagonals. So we have this, and we label them. So we have X, and we have the Y diagonal. Now, if we look on both sides of Y, we have two triangles. So we have a green triangle and a yellow triangle. Now, all we have to do, because we know the area of triangles or how to find that, is to find the area of both triangles and add them together. So we're going to start with the green one. So the area of the green triangle, or area of any triangle, is half base times height. In this case, we have a base is y, and our height is half of x, because we have half of x on each side of y. So now we just substitute those into our equation, and we end up with a quarter of xy is the area of the green triangle. So 1 over 4 xy is here. Now that's exactly the same shape and area as the yellow one, so we'd also get a quarter xy here. So the total area is just 2 times that. So the area of a rhombus would be a half xy, or a half of the length of its two diagonals. Now a kite is quite similar to a rhombus. In fact, the equation ends up being exactly the same, but we have to take a bit of a different path. So again, we can cut it into two triangles using its diagonals. This time the triangles aren't the same. So we're going to have one above the x and one below y. And this time we're going to cut our x into two parts. So we have A is the part, we cut y into two parts. A is the y above the x line, and B is the y below the x line. So if we were to add A plus B, we're going to get y. So now we need to find the size of the triangle ABD. So the area of ABD. And if we substitute in our values, we're going to get half AX. We need to find triangle BCD. Substitute those in, we're going to get half XB. And now we just need to add these two together. So we add the two triangles, and we're going to get this. Now we can use our algebraic knowledge, and we can separate to get a half X A plus B. And now remember, A plus B is the same as y, so we can substitute this for y, and we're going to get a half of x plus y. So, like with a rhombus, for a kite, our area is a half times the length of the two diagonals. Finally, we're going to look at the formula for the area of a trapezium. So, for a trapezium, what we're going to do is copy it and put it next to itself. Now, you might see that we've made a certain shape. So here, we've got A down the bottom is the same as here, and the B here is the same as this one here. Now, if this was our perpendicular height, this might help you recognize the shape. We have here a parallelogram. So the area of a parallelogram is just the base times the height. We've looked at that in a previous video. So, we just need to substitute in our values. So we have here, our base is this part here. So it's A plus B. So we put that in here, base is A plus B, and our height is this here, H. So the area of a parallelogram is A plus B times height. However, this here isn't a parallelogram, we're trying to find the area of a trapezium. So we need to remember that we've made two, so we've doubled the amount of area we have by taking this and putting it there. So now we need to divide our area of a parallelogram by 2. We end up with the area of a trapezium is a half times the height times the length of the bottom and the length of the top. And we end up with this formula here. So these are the three different rules or area rules that we've made, and we're going to need to use these for the rest of the lesson. So we're going to try to find the area of this rhombus using the rule. So remember, the area is a half times the length of its two diagonals. And these are its diagonals, 4 centimeters and 6 centimeters. So its area is just half of 4 times 6. So area is going to be 12 centimeters, 12 square centimeters. Now with a kite. This time we've been given one diagonal's length, but we don't know what the other one is. And we have the overall area. So we just use our formula. Area of a kite is a half xy. We substitute in the area, which we have. And we have the x, but we don't have y. So then we get 30 equals 2y. So y is going to be 15 centimeters. And now we want to find the area of our trapezium. So remember, we have our area of a trapezium is half height a plus b. So now we substitute in our values. A half of 6 times 6 plus 10, which is a half of 6 of 60, which equals 3 times 60, which is 180 square centimeters. And now we've been given the area, and we need to find the perpendicular height. So we use the same equation, half height a plus b, we have 40 equals a half h, 4 plus 6, so 40 equals a half h times 10, 40 equals 5h, so h is going to equal 8 centimeters. Now it's your turn. You have the two diagonal lengths of this kite. Can you find what the area is? So we use our formula. Area is half xy. So it's half times 4 times 6. So 2 times 6. So 12 square centimeters. Can you find the area of this rhombus? So our area, half xy, so it's going to be a half of 8 times 12, which equals 4 times 12, which is 48 square centimeters. Can you find the area of this trapezium? Area of a trapezium is half height times a plus b. So we get a half of 6 times 9 plus 10, which equals 3 times 19, which equals 57 square centimeters. Now can you find the length of the perpendicular height of this trapezium, given its area and the length of the other two sides? So, area is half height, a plus b. So 144 equals a half of h, 10 plus 14. 144 equals a half h, 24. 144 equals 12 times h, so h is going to equal 12 centimeters. So this is a summary of what we've covered in this lesson. I hope it's made sense. Please let me know if it hasn't. Thank you.